All right, year 11. So this is example 11 from chapter 4, exercise 4E to do with circles. Let's have a look here. So assuming you've watched all the other videos, now you're pretty comfortable with sketching circles. Here it's in a different form than what we're used to. And here you need to be able to do completing square from quadratics or chapter 3. Okay, so here we go. X squared plus y squared minus 6x plus 4y minus 12. Let's rearrange this. Let's keep all the x's together. So x squared and minus 6x. And then the y squared with plus 4y. Keep the minus 12 on the outside. So here, if I rewrite it, I've got x squared minus 6x. Okay, and the other one is plus y squared plus 4y. And I'm going to add the 12 on both sides. So negative 12 plus 12 cancels out. And then you get 12 on the right-hand side. Okay? Now, the reason why I reorganized it is because what we're used to seeing in a circle format is that it's usually x squared plus y squared is equal to r squared, right? But notice this is a perfect square and this is a perfect square. What you currently have is not a perfect square, so what you have to do is you have to transform this into a perfect square. And in order to do that, well, we know how to use completing the square. So the question is, if it's x squared minus 6x needs to be a perfect square, what number should be at the end? Okay, so what am I missing to make this a perfect square? And hopefully you remembered that the number that you're missing is actually half of the b term, so negative 6, half of negative 6 is negative 3, and then square it. So what I'm missing is a 9. So I need a positive 9 to make that a perfect square. Okay, so that means this is x minus 3. Try expanding that if you've forgotten it. But if you expanded that, that should give you x squared minus 6x plus 9. Okay, but remember that plus 9, I just chucked it in. This is made up. So that's why if you put in a plus 9, you also must put in a minus 9 because it never existed. Right? All I wanted was that perfect square, which I've got, but you can't just randomly add a plus 9. You need to minus the 9 as well. And then same thing to make this section, this y section, to be a perfect square, I also need to figure out what number am I missing. And same thing, half of the b term, so half of the coefficient of y, half of 4 is 2, square the 2 is 4, so I'm actually missing a 4, but since I'm putting on a 4, that will make it a perfect square. It would be y plus 2. Try expanding that. It will be exactly this term here. But remember, since you put on the plus 4, well, then I have to subtract that 4 because it was never there. Okay, it wasn't actually there. I just put it in to make it a perfect square. That's what completing the square technique is. And so what you're left with is, since this is a perfect square, you still have a leftover of minus 4. And you also have a leftover of a minus 9. Don't forget that's a plus there. So now that you've got something that's very similar to a circle again, we're going to move all the numbers, so the negative 9, the negative 4, all onto the one side. Collect all the numbers together. So if I add 9 and add 4, so add 9 and add 4 on both sides, really you're adding on 13. And what do you get? You get this equation now. So you still have this nice perfect square. It's x minus 3 squared. Plus, this is still a y plus 2 squared. But since I've moved the 9 and the negative 9, negative 4 across, 12 plus 9 plus 4 is 25. And then look at that. Isn't that a form that you're more familiar with? Now you know this is your radius. So the radius is equal to 5. This clearly tells me down by 2. And this also tells me right by 3. Okay, so when they say find the radius, the coordinates of the center, well, I know that the center must be at right by 3, so it's 3. Down by 2 means negative 2. Radius, I now know it is 5. And then to sketch this graph, well, let's do it. 3, negative 2, so to the right by 3, down by 2. Here's my center. That's my center, 3, negative 2. And I know the radius is 5. So radius is 5, so from negative 2, if I add on 5, that will bring me to 3. And then negative 2 minus 5 will bring me down to negative 7. So let's say negative 7's there. So that's a height of 5. That's a bottom of 5. And then I need a width of 5 as well. So 3 minus 5 gives me negative 2. and 3 plus 5 gives me 8. Okay, so if I had to keep within those parameters, you can see that the circle should look something like this. So let's try to draw a circle reaching there, coming all the way down, coming back up. All right, that's not too perfect. Let's just shorten it a bit. Drop this down a bit. No, that's not right. Let's see if I can... Actually, you know what's easier? If I just change that -7. And you just said -7's here. There you go. And I just shift this one up a bit. Let's say 3. There you go. So max height of 3. Bottom range is -7. And the max domain is clearly at 8. So you get 8. Let me just move that across and make it look nicer. So let's say 8 is here. And the minimum for the domain is -2. Center is at 3, -2. Okay, let's see if that's true. I'm going to draw the circle now. Let's see if that's true. So they gave us x squared plus y squared minus 6x plus 4y minus 12 equals 0. Let's see if that's true. Let's zoom in and you can see there, that's exactly what we said before. Max width is 8, minimum width is -2, bottom should be -7, and then all the way up to max 3. Center should be at 3, -2, and that is true. Okay, so there you go. So if I zoom in a bit more, you can see how many units across. It's 1, 2, 3, 4, 5. So that tells me a radius of 5. Okay, and that's how you do example 11.